Okay. Am I audible to everybody? Sorry about the issue earlier. Mm, okay. Am I audible to everybody? So that was it about interactive session one. Okay. 6:45. I mentioned that I'll be back at 6:45. Okay. So did you understand this question? Did you calculate this? Did anybody calculate this? Okay. So let's calculate it. As we have already discussed here, Cu is d60 by d10 and Cc is d30 square divided by d60 into d10. So our Cu is d60 over d10 and our Cc is d30 square over d10 into d60. So this will be 7 over, sorry, not 7 over 60. We need we need the values of sieve openings for 10, 20, sieve number 10, sieve number 20, sieve number 40. Okay, so sieve number 10 is 2 mm, sieve number 20 is 0.85 mm, and sieve number 40 is 0.425. Okay, so our D60 is 2 mm and D10 is 0.425. Can you calculate this? This comes out to be 4.7. And this is D30 0.85 over D10 is 2 mm and D60 is 0.425 mm. Let's calculate this. This comes out to be 0.85. And here you can see that at 60% is retained on the 2 mm sieve. So this is basically gravel because 60% is retained on the 2 mm sieve and it is poorly graded. Why? This is okay. but this is too low. Okay, so this is basically a GP soil. Is that fine? And because below 0.75, below 75 micron, only 3% was there. So we do not need to calculate the uh, classification for the fine fraction. Okay, so let's move on to today's class. Okay, so the interactive session 2, as I am aware, in the second week, what you have studied is the soil, water, air relations, or the phase relations, or the weight volume relations, and permeability. So in these relations, you have studied the types of densities of soil. You have studied indices like the void ratio, the water content, porosity, the specific gravity, and how they are, and the saturation. And in the types of densities, there is bulk density, there is dry density, saturated density, there is submerged density. These are the types of densities for soil. So let's focus on this part today. Let us move on to the weight volume relations. So as you already know that our soil is a three-phase system. If anybody has any question at any time, instead of typing it, I recommend that you unmute your mic because the chat is not visible to me. Okay, okay. So you know that this is a three-phase system in which you have solid, which is your soil mass, then you have the water, and then you have the air. This is the three-phase system. This gets converted into a two-phase system in two cases. First case is dry soil, completely dry soil. Here you will only have soil and air because there is no water. So your volume of voids will become equivalent to volume of air. Uh, and weight, total weight will become equivalent to weight of solids. Let me show here. This is volume of air, volume of water. This completely is volume of voids. Then we have volume of solids. This is weight of solids. Actually, let me draw it properly. It will be a better representation. So these are your solids. This is the water, and this is the air. This is completely the volume of voids. This is volume of water, and this is volume of air. This is volume of solids. And this completely is the total volume. It's very helpful to draw the phase diagram when you are calculating any type of weight volume relationship, because it gives you a clearer idea of what you are doing. This is the weight of solids. This is the weight of water. And this is the complete total weight. Why? Because air will not have any weight. This is the water. Okay. So now what we have been asked, okay, I was mentioning that the three-phase system gets converted into a two-phase system in two cases. First is the dry soil, in which you only have a weight of solids, which becomes the total weight. These are the solids, this is the air. Total weight equals weight of solids. And total volume, this will be VV. And VV becomes VA. Second case is saturated case. In saturated case, all the voids of the soil are filled with water. So there is no air. So this will be your total weight, and this will be your total volume. Volume of voids will become equivalent to volume of water. Okay. So we have been asked to derive the expression for saturated unit weight of soil. We can do this two ways. Either we can take the formula that that's the master formula for every kind of weight volume relationship, or we can simply do one thing. We can take from scratch. From scratch, let me take. Uh, Let me take this part. Okay. So this will be your water, this will be your solids, and you know what basically density is. Density is equivalent to total weight by total volume, isn't it? In this particular case, this density will be gamma saturated. Why? Because our case is saturated. So the total weight is weight of water plus weight of solids. And the total volume is volume of solids, volume of water. Now, what we can do is We can take these. The first thing we will do is we will write this as okay. So let's divide by volume of water here. Like if we take volume of water common here, this will become over volume of water divided by Vs by Vw plus 1 plus, let's do the same here, Ws by Vs over 1 plus Vw by Vs. So this is weight of water by volume of water is our gamma W, 1 plus Vs by Vw. Instead of Vw, we can write Vv here, isn't it? Because we see Vv is equivalent to Vw. So first let's do that. Let's write Vv and Vv, weight of solids. Just one moment. Give me one moment, please. Okay, I think I went in a little uh, straight direction. We know that water content is equivalent to weight of water over weight of solids. So we can write weight of water as water content times weight of solids, isn't it? So let's replace here W times Ws plus Ws over Vs plus Vw. Other thing we could have done was we could have taken this Ws common, and then we would have Ww over Ws plus 1 over V. And we know that this is equivalent to the water content is equivalent to Ws into W plus 1. This is Vs by V. Now let's try to change the Vs, because typically in field you don't get exactly Vs value. what you get is like weight of water, the total weight, but you will not get Vs because that's a difficult value to obtain in the field. You have to dry the soil then. Okay, so we know that Gs equals weight of solids over volume of solids. Then we can write volume of solids is equivalent to Gs over Vs, Gs into Vs. So let's replace here. This will be Gs 1 plus W over Vs over V. Okay, this is equivalent to Gs 1 plus W, you know, Vs over Vv plus Vs. And if we divide the numerator and denominator by Vs, we will get 1 by Vv by Vs plus Vs by Vs. This is Gs 1 plus W. And Vv by Vs is the void ratio and Vs by Vs will be 1. So this will give us Gs 1 plus W saturated over E plus 1. Okay, so basically uh, this is the answer. I'm missing the term. There's a gamma W here. There's a gamma W here. The specific gravity is the density of soil over the density of water. There is a gamma W here. Okay, so that's the answer. Any doubts in this question? Okay, so let's move on to the next question. For a moist soil sample, the following are given: the total volume, the total mass. Let's draw a three-phase diagram for this. This soil is moist, it's not saturated. So the total mass is 2350 kg and the total volume is 1.2 meter cube. Moisture content is 8.6%. We know that moisture content is weight of water over weight of solids, which is 8.6%. Specific gravity of solids is 2.71. And first of all, we need to determine the moist density. This is an easy step. A part is easy because this is just bulk density, which is weight, total weight over total volume, which will be 2350 over 1.2 kg over meter cube, and this will come out to be 19 58.33 kg per meter cube. This is simple. Next, the dry density. We know that gamma dry is equivalent to gamma B over 1 plus W. This will be 2350 1.2 1 by 1 plus 0.086. Okay, let's calculate. This will be 1803.3 kg per meter cube. Okay. So anybody wants to calculate the void ratio? Can somebody tell me what the void ratio will be? Is anybody trying to find the void ratio? Or should I move on to the next part? Like, Yogita? Yogita, are you in class? Or Ambika? Okay, so let's calculate the void ratio. Can anybody at least give me a hint how we can calculate the void ratio? We know that we can simply write, we would have used GW is equivalent to ES, but we don't know the S. We know we know this, but we don't know the S. So let's go on to gamma B is equivalent to GS gamma W 1 plus W over 1 plus E, isn't it? Or we can go with gamma D equals GS gamma W by 1 plus E. But excuse me, let's go on with this. It's the same thing. Okay, so gamma bulk was 2350 over 1.2. 2350 over 1.2 equals GS is 2.71 2.71 into, so here you have to be careful. This is kg per meter cube. So we have to take the gamma W in kg per meter cube. We take it as 1 gram per cc, but it is 1000 kg per meter cube. So this will be 1000 1 plus 0.086 over 1 plus E. So R1 plus E will be equal to 1.503, and our E will be equal to 0.503. Okay, so let's move on to the next part. We have to calculate the porosity. Anybody knows the relationship between porosity and void ratio? So, porosity basically is volume of voids over total volume, and void ratio is volume of voids over volume of solids. So, if we take this n is equivalent to volume of voids over volume of voids plus volume of solids, so it will be 1 by n equals volume of voids plus volume of solids over volume of voids. That means 1 by n equals 1 plus volume of solids by volume of voids, which is inverse of E. So basically n comes out to be E over 1 plus E. So here we will have 0.503 over 1.503, which will be 0.33. So n comes out to be 0.33. The next thing that we have to calculate is the degree of saturation. Now that we know the void ratio, we already know the GS and the W, we can simply calculate the degree of saturation through GW equals ES. That implies 2.71 into 8.6, was it? Yes, equals 0.503 into S. So our S will be 2.71 into 8.6 over 100 into 1 by 0.503. Let's calculate 2.71 into 8.6 divided by 100 divided by 0.503. So this comes out to be 0.463, which is 46.3%. This is our degree of saturation. Okay, so next is volume of water in the soil sample. How do we calculate the volume of water in the soil sample? In soil sample, we know W equals weight of water over weight of solids, and GS equals weight of solids over volume of solids, over gamma W. And how do we convert this volume of solids here? Okay, weight of solids will be will be our weight for gamma D. Okay, let's try to solve this in an elementary way. Okay, like I mean from a basic instead of going for any formula. Let's go with the basic. So volume of solid, we know rho W is equal to weight of water over volume of water. So volume of water will be weight of water over rho W. And weight of water is total weight minus weight of solids. And this will be we will divide by total volume, both denominator and numerator. This will be gamma bulk minus gamma dry over into volume. So let's calculate if we get it right. Gamma bulk is 1958.33 minus 1803.33, 155, 155 over 1000 into what was the total volume? 1.2 meter cube. 1.2 comes out to be 0.186 meter cube, which is the correct answer. Okay, so anybody has any questions up till now? Any questions? Okay, let's move on to the next question. Following data are given for a soil: the porosity, the specific gravity, the moisture content. Determine the mass of water. Determine the mass of water to be added to 10 meter cube of soil for full saturation. Let's try to understand what the question is saying. We have been given the porosity. Like basically what we have been given is that if I give you a soil sample of volume V, how much volume will be occupied by the solids and how much of the volume will be free for occupation by water and air. So you see, we have been given porosity, specific gravity of solids, moisture content, and we need to determine the mass of water to be added to 10 meter cube of soil for full saturation. So volume is 10 meter cube. We have been given the water content, based on which we will know that how much void space is already filled with water. So from porosity, we will know the total void space. From moisture content, we will know the void space that is filled with water. And then we need to determine the mass of water to be added for full saturation. First, we need to determine this volume, which will be V of V minus V W. This volume, then we multiply this volume by rho W and we will get our answer, isn't it? So let's try to calculate this remaining volume. So we know gamma B equals GS gamma W 1 plus W divided by 1 plus E. And from E, we can calculate the porosity. N equals E over 1 plus E. Sorry, from porosity we can calculate the E. So 1 plus E over E equals 1 by N, and 1 by E plus 1 equals 1 by N. 1 by E is equivalent to 1 by N minus 1, and E equals N over 1 minus N. So let's calculate E. 0.4 over 1 minus 0.4. So it comes out to be 0.667. Let's use it here and we will know the gamma bulk. GS is 2.68 into, we are given in meter cube. So let's take 1000 cc, 1000 kg per meter cube. 1 plus 0.12 over 1 plus 0.667. So let's calculate 2.68 into 1000 into 1.12 over 1.667. So gamma P equals 1800.5.6 kg per meter cube. This will be basically gamma B is equivalent to 18 kilonewton per meter cube. Okay. So from gamma bulk, we calculate the gamma saturated. Not from gamma bulk, after gamma bulk. Okay. So gamma saturated equals 1 minus N. Basically, this is the formula. GS plus N rho W. Actually, what this is coming from is gamma saturated formula is G plus W by 1 plus E times gamma W. So we can use this formula itself as a sign. Excuse me, just a moment. Let me cross check this. Okay, this is G plus E actually. I was mistaken here. So the first question that we did actually, this is not incorrect, but it is incomplete. What we have done here. If we write GW is equivalent to ES and S is equivalent to 1 because of saturation, then W is equivalent to E by G. And if we substitute it here, E over G, and we take the LCM, we will get the same result. 1 plus, sorry, G plus E over 1 plus E times gamma W. Okay. So uh, let's calculate gamma saturated. 2.68 plus 0.67. 0.67 over 1 plus 0.67 into 1000. This comes out to be 2006 kg per meter cube, which is basically 20 kilonewton per meter cube. Okay, so we know that gamma bulk is equivalent to total weight over total volume. One second. Screen is glitching a little. Okay. And gamma saturated is basically rate of gamma bulk is equivalent to weight of solids plus weight of water, this one, over volume, and gamma saturated is equivalent to weight of solids but the complete weight of water. Like when this is saturated, this is bulk, and if the same thing was saturated, what we have calculated by gamma saturated is this complete is completely filled with water here. W saturated. So this is weight of solids plus W saturated over V. And if we subtract these, we will get this water content minus this water content. And this is what we actually are looking for in the question. So the answer will be gamma B minus gamma sat, which is 8 gamma saturated minus gamma bulk, which will be 20 minus 18, which is 2 kilonewton per meter cube, which is equivalent to 200 kg per meter cube. We multiply this by the volume we are given, we will get the weight into volume. So weight of water required will be 2 kilonewton per meter cube into 10 meter cube, which will be 20 kilonewton, uh, which is basically 2000 kg. Is that fine? Is that fine for everybody? How we reached this? Anybody has any questions till now? Is the flow of the question solving okay? Okay, let's move on to the next question. So these were just basic questions. Now we've got a good question. So an embankment with crest width. Okay, let's take a 10-minute break. Uh, let's rejoin. Uh, let's rejoin at 7:45. Let's take a 10-minute break. Is that fine? Okay. Okay. Uh, is everybody back? Okay, let's. Actually, there are 2 minutes left. Is everybody back? Can I see a show of hands? Thank you, Hitesh. Are the rest of the people back? Okay, let's continue. So, the question mentions an embankment with a crest width of 25 meters. Let's draw this. The crest width, actually, let's do one thing. Let's draw a proper polygon. Okay, so this is the embankment. The crest width is 25 meters. The height is 15 meters. And the slope is one vertical to two horizontal. Actually, let us. So it will be something like this: one vertical, two horizontal. Okay, flatter, I mean to say. This is 25 meters. Height is 15 meters. And this is one vertical, two horizontal. So let's calculate the length of the base. The vertical is 15, so the horizontal will be 30. 30, so the total will be 60, 70, 85. Okay, so this embankment needs to be constructed. For the embankment, the gamma, the total bulk density required is 17 kilonewton per meter cube. Okay, so gamma B required 17 kilonewton per meter cube. Soil for the embankment has to be brought from a borrow pit. So there is a borrow pit from which we are excavating this soil and we're transporting to make this embankment. And the soil at the borrow pit has the following uh, properties. E is 0.68, GS is 2.68, and W is 10%. Determine the volume of the soil from the borrow pit that will be required to construct an embankment of 1,000, let's say 1 kilometer long, 10 kilometer long, which means 10 kilometers in this direction. In this direction. Okay. So if you see here, we have been given gamma for the embankment because we uh, mm, we control how much dense we will make this soil when we are making this embankment. But here density is not an issue because once you take the soil out, it will not matter how dense the soil was. All that will matter is how much soil we need from here to create this dense of an embankment of this volume. Okay, so first thing we will do is we will calculate the dry unit weight at the borrow pit. from the data that we are given, because this dry unit weight will correspond to our weight of solids, as I mentioned earlier, over volume total. Okay, so this is 2.68 into 1000 over 1 plus 0.68. This comes out to be, okay, 3941 kg per meter cube. Second thing that we want to know is total volume of the embankment. Like, what is the volume of uh, the soil that you will be putting here? So the volume of embankment will be, uh, you know, this will be 15 over 2 into 25 plus 85. This will be the area multiplied by your length, which is 10 kilometers. See, this is in meters, so we will write 10,000 here, which is 25 plus 85 into 15, 25 plus 85 plus 2 plus 15 into 10,000, which will be 8250. Let's make it 1 kilometer. There are too many zeros here. Okay, 825000 meter cube. Okay, so this will be the volume of the embankment. And now we need to know the volume that we require from the borrow pit. So the principle that we will use is that the weight of solids required at embankment will be equal to, uh, the gamma bulk is 17. Was it 17? Yes, 17 kilonewton per meter cube. So this is equivalent to total weight over total volume. We know the total volume, so we can calculate the total weight, which will be kilonewton per meter cube, 17 into 825,000. 825,000 kilonewton, which is 17 into 825, 14025,000 kilonewton. So this is the total weight required of uh, for this volume total, and this bulk density. The total weight of solids that we require is this much. So from the borrow pit, this is the Ws actually that we require. Now we have already calculated the Wd, which we know will be Ws over volume, isn't it? So from the data about the Gs, W and E, we calculate the gamma D, which came out to be 3941 kg per meter cube. Okay, and actually this is a little too high. I may need to G gamma W 2.68 over 1.68. Okay, there is a mistake here. I was thinking why this value is coming out to be so high, because usually what you get is in the range of 2000, up to 2000 you will get, not more than that. So there is a calculation error here. 2.68 over 1.68 into 1000. This is 1595 kg per meter cube, which is all equal to 15.95 kilonewton per meter cube. Usually we deal with kilonewtons, and you will get a value from 15 to 21 kilonewton per meter cube for soils, not more than that. You see, even concrete is 24 kilonewton per meter cube. See, so that is too high. This was coming out to be 39. You should already have known that there was something wrong there. So 15.95 kilonewton per meter cube. 15.95 kilonewton per meter cube equals 14025,000 over V. So our volume will be equal to 14025,000 over 15.95, which will be about 879,310 meter cube. So yeah, this should be our value of volume required, total volume required from the borrow pit. Is there any confusion in this question? Is there any confusion in this question? Okay, Let's move on to the last question for today. This is for relative density. This question is for relative density. So basically, when we want to know relative density is for coarse grained soils. Uh, if I give you a pile of sand in your hand and tell you that how is this sand performing in the field. When I give you this sample, the density of the sample does not uh, matter anymore, because the density that is in the field of this soil, that is what matters. I have taken this out and I have given it to you. Now I have disturbed the sample and the density is not the same anymore, because uh, further you may study that fine grained soil, clayey soil, at least you can get a core sample. A core sample you can get, it will stick together. It will be kind of a lump of soil. You can calculate density from that, but not for coarse grained soils. Once I've taken this out, I've given this to you, you will have like you can tell me the characteristics of this sand, but unless and until you know that like what is the density of this sand in this field, you will not know how the soil will perform. Now, if I tell you the density of this soil, say uh, density or void ratio, this is interrelated here for dry soils. Let's say if I tell you the density in field, but I have not given you the soil sample, again you are lost because you don't know the characteristics of this soil. So, what are the characteristics that we are talking about? If you take a soil in a container and you shake it, vibrate it, it will densify to a maximum limit. And if you pour the sand, sorry, meant to say sand. If you pour the sand loosely from a height, you can fill this whole container. Okay. And then you shake it, it will densify. So this will be its minimum density and this will be its maximum density. So these two values are characteristics for a sand. I give you a sample, you calculate these two values. Then I tell you what the gamma in the field is. Then you can make a judgment if this gamma is more close to gamma max or is it more close to gamma minimum. If it is close to gamma minimum, you will say that it's a loose soil. If it's close to gamma maximum, you will say it's a dense soil. So we calculate the relative density, which will be the gamma maximum minus gamma, like on a scale, if I have gamma minimum here and I have gamma maximum here, and this is where my density is. This is basically this gamma maximum minus gamma minimum, this value over gamma maximum minus gamma minimum, this value. So this is our relative density. Concept of relative density, why we require it, and okay, so let's calculate our relative density. Let's do the relative density question. For a given sandy soil, E maximum is 0.75, E minimum is 0.4, GS is 2.68, and gamma is 18. W is 12%. Okay. So we need to calculate the relative density. So what we will do, can anybody answer? We can do, we have two options. Either we calculate gamma maximum from here and gamma minimum for here, or we calculate and we use it in the formula relative density equals 1 by gamma minimum minus 1 by gamma divided by 1 by gamma minimum minus 1 by gamma maximum. Or we can use the formula relative density is equal to E max minus E over E max minus E minimum, for which we calculate E from here. Let's do this part. E equals, uh, we know that gamma equals G gamma W 1 plus W over 1 plus E, which equals 2.68 into, let's take in gram per cc, 1 into 1 plus 0.12 over 1 plus E equals, no, I have to take this in kilonewton. It will be 10 because the gamma is in kilonewton per meter cube. So let's calculate. 2.68 into 10 into 1.12 over 18. So 1 plus E will come out to be 1.667. E is 0.667. And then our relative density will be E maximum 0.75 minus 0.667 over 0.75 minus E minimum 0.4. And this comes out to be 0.229, 22.9%. Okay, any question in this? Thank you very much, guys. I think that's it for today. Hope to see you next week. Okay, bye.